Hello everyone, I am Yoshita. Welcome to my YouTube channel. Today I am going to discuss about Venturimeter. The contents that I am going to discuss on Venturimeter are its introduction, construction of Venturimeter, applications of Venturimeter, working principle, Venturimeter equation, advantages and disadvantages of Venturimeter. Now discussing firstly about its introduction. Venturimeter is a type of flow meter that works on the principle of Bernoulli's equation. This device is widely used in the water, chemical, pharmaceutical and oil gas industries to measure the flow rate of fluid inside a pipe. The pipe cross-sectional area is reduced to create a pressure difference which is measured with a manometer to determine the rate of fluid flow. So the Venturimeter is a differential head type flow meter that converts pressure energy into kinetic energy. The principle of the Venturimeter was demonstrated by Giovanni Battista Venturi, hence the name Venturi. But it was firstly used in practical metering applications by Clemens Herschel. In this first article, we will explore the parts, working principles, equations and applications of the Venturimeter. And now coming to the working principle of Venturimeter. When a fluid flows through a Venturimeter, it accelerates in the convergent section and then decelerates in the divergent section. The present difference between an upstream section and the throat is measured by a manometer. Using the differential pressure, applying Bernoulli's equation and continuity equation, the volumetric flow rate can be estimated. In the next section, the equation of Venturimeter to find the discharge value are discussed. Now coming to the construction of Venturimeter, the way how it is constructed. Firstly, it has the four parts: cylindrical inlet section, conical convergent section, cylindrical throat and conical divergent outlet. Cylindrical entrance section. Venturi entrance is a straight cylindrical section with a length equal to 5 to 8 times the pipe diameter. Convergence conical section. In this section, the Venturimeter tube diameter gradually decreases. The conical angle is normally 210 plus or minus 20. While the liquid flow inside the Venturimeter, the velocity of fluid increases at the expense of a decrease in pressure. Now coming to the cylindrical throat. Throat consists of a minimum Venturimeter diameter. In the throat section, the velocity is maximum and pressure is minimum. Normally, throat diameter is equal to 1/3 to the 1/4 of inlet pipe diameter. Diverging conical section. At this section of Venturimeter, the tube diameter gradually increases, so the pressure is built up again to original inlet pressure. The cone angle is 5 to 70. British standards BS 1042 specifies two conical angles 5 to 70 and 15 to 150 for the outlet cone. Now coming to the Venturimeter equation, Bernoulli's principle states the relation between pressure, kinetic energy and gravitational potential energy of a fluid inside a pipe. The mathematical form of Bernoulli's equation is given as P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2, where P is equals to pressure inside the pipe, rho is density of the fluid, g is gravitational constant, V is velocity, Z is elevation or head, A is cross-sectional area of the pipe, D is the diameter of the pipe. Now applying continuity equation between the same section 1 and 2, we get A1 V1 is equal to A2 V2. Putting this value of V1 in equation 1 and solving, we get Q is equals to A1 A2 by rho A1 square minus A2 square into root 2GS. This cube represents the theoretical discharge of Venturimeter in ideal conditions, but in actual practices, there will always be some fractional loss. Hence, the actual discharge will always be less than theoretical discharge. So, to calculate the actual discharge, the above Q is multiplied by CD, called the coefficient of discharge of Venturimeter. So, the actual flow rate through the throat of the Venturimeter will be given by the following equation. Suffixes 1 and 2 are used to denote two different areas. One denotes cylindrical inlet section and 2 denotes the throat section. Here Z1 is equal to Z2. So we get the equation like H is equals to V2 minus V12 by 2G. Now coming to the applications of Venturimeter. Venturimeters find wide applications in fluid industries. The major application of Venturimeter includes it is used in engine carburetors, that is automobile section, to measure airflow, and also used in process industries to measure and control process flow. In the medical industry, blood flow in the arteries is measured by Venturimeter. It is also used to measure the fluid flow inside pipeline. Now coming to the advantages of Venturimeter. They provide accurate results. The accuracy of Venturimeter is not dependent on temperature and pressure inside the pipe. It has no moving parts, very low energy loss, wide applicability for water, suspended solids, gases, slurries, chemicals, dirty liquids, etc. High discharge coefficient and very low pressure drop. It can be installed in horizontal, inclined or vertical direction. It has very less chance of being clogged. The pressure recovery of Venturimeter is very high. The discharge pressure is almost near to inlet pressure. Now coming to the disadvantages of Venturimeter. Venturimeter are large in size, so difficult to install where there is space constraint. Expensive as compared to other types of flow meters. Limited range of flow measurement. And finally, not suitable for very small diameter pipes. Thanks for watching this video.